In this video, I'm going to take you through installing and running a simple Helios test case on Windows platforms. And I'll illustrate this through 3 different possible approaches that you might choose for working with Helios. The first being using the CLion Interactive Development Environment, or IDE. If you're in academia and you have access to the free JetBrains for Education licenses, this is the approach that I would recommend and what I use personally. JetBrains makes really nice IDEs, and when it comes to working with Helios, it just makes setting up and running simulations very easy, and it has a lot of really nice features. I'll also talk about using Visual Studio Code. So if you already use VS Code for other languages or other programming applications, you might just prefer to stick with one IDE. So I'll go through how to do that, and that will work perfectly fine for developing with Helios. The third is using a command line interface. So if you're a little bit old school and you like working through the command line, then you might choose this approach, which will also work, and I'll take you through how to set that up. If you already know which of these 3 approaches that you want to use, then you don't need to watch this entire video. You can just skip to the part about your platform of choice. However, there is some background material that's common to all 3 different approaches that you want to watch before doing that. Regardless of the method that you're using for running Helios, we're going to need to do 2 things first. The first is that we're going to download and install Microsoft Visual Studio. And importantly, if you already have Visual Studio installed, you're still going to want to pay attention to this step because it's important that you enable the C++ tools as part of Visual Studio. Otherwise, it's not going to work. After that, we're going to go through how to install the CUDA Toolkit. So this is only if you're using GPU-based plugins and you have an NVIDIA GPU, which is required in order to run the GPU plugins. You're also going to need to install the CUDA Toolkit. All right, first step is that we're going to install Microsoft Visual Studio. So I've got a fresh install of Windows here. Nothing's been installed on it so far. So we can open up our web browser and just type in Visual Studio download. And we could come to this first option here. So as of the time of that this video was made, the latest version is Visual Studio 2022, and you're most likely going to want the community version as it is free. You can just click on that to start the download. It's going to start downloading here. And we can open up that file and run it. It'll take a second to check out your configuration. Okay, once this window comes up, the very important step here is to scroll down and find Desktop Development with C++. This is going to be necessary in order to compile our C++ programs. So that's all we need to do. You'll see down here this install button. You can go ahead and click that to start installing. If you already had Visual Studio installed and you need to add the C++ libraries, then you can run this installer, and then at this point when you check that box, it will say modify instead of install, and then when you click modify, it'll go ahead and install those additional packages that are needed. All right, after quite a lengthy install, we now have Visual Studio installed. We can go ahead and close this out. We actually don't need to open Visual Studio at this point. Our next step is going to be to install the CUDA Toolkit drivers if you want to use Helios with your GPU and the GPU-based plugins such as the radiation model. And Helios supports GPUs with compute capability 3.5 or greater. And if you have a compute capability less than 5, that requires some special legacy options to be enabled when you build Helios, which I will talk about here in a minute. So if you have no idea what compute capability means, it's essentially the capabilities of your GPU in terms of its hardware and architecture. So as newer GPUs come out, they have higher compute capability. Compute capability 3.5 started, I think, around 2015 or 2016. So unless your computer and GPU is really old, there's a good chance that you don't really need to worry about this. But if you want to check what your GPU's compute capability is, then I'll put a link down in the description to NVIDIA's website. You can click on it and go and figure out what your compute capability is. And again, CUDA is an NVIDIA-based product, and so you need an NVIDIA GPU in order to install CUDA and to use the GPU-based plugins within Helios. Okay, let's go back to our Windows desktop here and install the CUDA Toolkit. You can go to our web browser and type in NVIDIA CUDA download. And the latest version as of the time of making this video is CUDA Toolkit 12.2. You should usually be okay installing the latest version of CUDA Toolkit unless your compute capability is not supported. So starting in CUDA Toolkit 12.0 and greater, the compute capability 3.5 is no longer supported. So if you have compute capability 3.5, it's recommended to install CUDA Toolkit 10 or 11 and then enable the legacy flag that I'll show here in a minute. So we can click on this. It's just going to ask you for your operating system, which is Windows, and your OS version. Click on that. If you install from local, it's just going to take a little bit longer because it's going to download everything first, or if you install over the network, it'll be a little bit faster. So we'll download the base installer here and wait for that to finish. All right, it's all ready to go here. Go ahead and run that. Click OK. Agree to the license. You can just do the standard installation. Okay, after another very long install, we've now reached the end. You can go ahead and view the summary, and once that's done, there's nothing else that we need to do for the moment. However, I do want to just ask you to take a look at where CUDA was installed. If you installed to the default location, which is what I did, it should be installed under your C drive, Program Files, NVIDIA GPU Computing Toolkit, CUDA, and then version 12.2. And this is where all of your components of CUDA are, and in this bin folder is where the actual executables and DLLs are. So we're going to need to know that path for later once we put that in to our IDE or whatever we're using to run Helios, such that it knows where to find the CUDA libraries that you just installed. All right, there's one last thing that we need to do here as far as the GPU setup goes. We need to basically edit our registry to increase the GPU timeout. So by default, the operating system is expecting that when doing normal rendering tasks with the GPU should respond fairly quickly. And if it doesn't, it assumes that something's wrong and it triggers a timeout. So if you're running GPU applications that take a while to run, then you can potentially get this timeout error. So in order to do that, we'll edit the registry. So if we come down and do a search and type in regedit, And it will bring up this option to run the command reg edit. If you're not already administrator, then you need to right click and run as administrator. But if you click on here, it will open up our registry editor. And we need to browse through a bunch of these menus in order to find or create the timeout key that we're going to need to run GPU programs. So it just opened a bunch of these things automatically, but we want to browse to HKey local machine, which is already expanded here, and then go to system, and then go to current control set, and then to control, and then we'll find graphics drivers. And then from there, we can click on that. We want to see if there's a key already called TDR delay. In our case, it has not been created yet, so we need to go ahead and create that. So we'll come back to graphics drivers, right click on it, and go to new DWORD 32-bit value. And if you get an error here that says that you cannot edit the registry, then it's because you didn't run this as administrator. So let's name this TDR delay with T and D as capitals, the rest as lowercase. And then we can double click on this. Let's change it from hexadecimal to decimal. And then we can set our value at 600 seconds. This is usually okay. If you start to get an error, then you want to go ahead and increase that further. So the error says display driver stopped responding and has recovered. So if you're still getting this error, then you need to go and increase this value even further. So we can hit OK. And at that point, we can go ahead and close out of this. And you'll actually need to restart your computer in order for this to take effect. That's it for the general install. We'll move to the IDE or command line specific install. To install the CLion IDE, if this is the method that you've chosen, we're going to follow the steps listed here on the slide. First, we will create a JetBrains account such that we can download and use the CLion software. Then we will download and install the CLion IDE. Then we'll pull the Helios source code from GitHub into CLion, and then we'll set up the Visual Studio toolchain and CMake, which will allow us to build Helios programs. And then we need to add CUDA to the build path such that we can build the GPU related plugins. All right, let's go ahead and get the process started of creating a JetBrains account. So if we open back up our web browser, you can go to www.jetbrains.com. First thing that we want to do is create an account. You can click on, in the upper right-hand corner, this person icon. And you can go ahead and sign up for a free account. When you initially sign up, it will give you a free trial that you can use to go ahead and start running CLion immediately. If you are in academia, I would suggest getting yourself a free education license. So you can come up here to the top on the main homepage, go to education, and come over to free licenses for students and teachers. You can scroll down here and find Apply Now. So if you fill out this form, then JetBrains will get in contact with you and you can get yourself a free educational license for all of the different software packages that JetBrains offers. You'll notice here that there are two options, either for a student or a teacher. If you are a postdoc or researcher, there's no option specifically for that. I did get in contact with JetBrains to get clarification on that, and they did say that if you're a postdoc, then you can do the educational license as long as you're not using the software for commercial purposes. So you should be okay. If you're unsure, then I would get in contact with them just to clarify. But in most cases, postdocs should be okay to also use the free educational license. Okay, so once we have our account set up, let's go ahead and download CLion. So we can type in here CLion download. And this first option, download CLion, you should find that it automatically detects your operating system, and you can just hit this download button here. Once the download is finished, you can open the file. Be patient. If you just click it once, it'll take a second for it to open up the installer. Don't click it multiple times, and then you can click on Run. Should now bring up the CLion setup wizard. Pretty straightforward. You can just click through, install in the default location. I'm going to create a desktop shortcut. Click through to install. And once it's finished installing, we can check the box to run and go ahead and finish. When we open up CLion for the first time, it's going to ask us to log into our account so that it can get our license information. You can click login here. It's going to take us to the JetBrains website for us to type in our username and password. Then once it's successful, you can close out of your web browser and click on the button Activate. That should activate your license and give you this option to continue. Okay, now we want to open up Helios, and there's two ways that we could do that. If we had already gone to GitHub and pulled the Helios source code, then we could just go to Open here and browse to where that source code is. A little bit easier method is to just get it directly from GitHub, so we can click on Get from VCS. And if this is your first time opening up CLion, most likely Git will not have been installed, which it alerts us to here. However, it has this very nice link here where we can click and just automatically download and install. All right, now we can just type in the URL for the Helios repository on GitHub. And we can go ahead and hit clone, and it should pull the Helios source code from GitHub. We can trust the project, and it should open up a new project with the Helios source code. You can see the README page here. Then it's going to open up this project wizard that's going to help us set up our tool chain, which is what's used to build the project. It's most likely going to have MinGW as the default, which we don't want to use because we want to use Visual Studio. So we can highlight MinGW and hit the minus sign. That should take us to Visual Studio. And if the install went well and you enabled the C++ build tools when you installed Visual Studio, then it should be shown here. It should automatically detect it. It should also detect other things like CMake and the build tools. So we have all green check marks here, which suggests that everything's working correctly. It should auto detect your architecture. If it's not correct, you can come to this drop down and select your particular architecture. And go ahead and select OK. Now the next thing that we need to do is set up our build environment. So we come back up here, go to File and Settings. If we look in this Settings window on the left-hand side, there's a sub-option in this left pane called Build, Execution, and Deployment. You can expand that. If you click on the first menu item, which is Tool Chains, this is basically what we had already set up in the last step. If you needed to change something or you opened Helios directly without doing the pull from GitHub, then this is where you would go to change the tool chain. The thing that we want to change now is CMake, so that'd be the second option down. And this is going to give us information related to the build. And so it's automatically created this default build profile called debug. And there are three possible build types within Helios. We have debug, release, and release with debug info. So debug is going to build our project with debugging flags enabled. It's also going to completely turn off compiler optimization. So that means that it's going to run quite slowly, but it's going to have everything that we need if we want to debug our project and use the different debugging tools within CLion. If we were to build with release, this is going to not build with all those debugging flags, but it's going to enable compiler optimization. So our code is going to run typically about 3 to 5 times faster when we build with the release build type. And the third one that you can possibly do is release with debug info. This one is going to kind of be a hybrid between the previous two. So it's going to enable compiler optimization. So it's going to be fast. It's also going to build with debug flags. However, the downside to this is that when you don't disable compiler optimizations, it can mess with some of the debug info, like line numbers. It may reference an error to a specific line, and that line could be off. So it won't really be that useful. So this one isn't really recommended. We're going to build with debug to start, the one that it chose automatically. The next option down is our tool chain. So you can see that it says use default and Visual Studio is selected. We only installed one tool chain, which is Visual Studio. So that's the only thing that could be selected. We don't really need to do anything here. The next one is the generator. This one is important. So you'll see that it says use default, and then the one that it's selected is nmake makefiles. We do want to use nmake makefiles. However, CLion can change its mind on this and dynamically change the generator. And so we want to open up this dropdown and come down and explicitly select nmake makefiles. And that's because sometimes when CLion decides to change the generator, it can sometimes select Ninja, for example, and then Ninja doesn't work with Helios. So if you find build errors that say Ninja all over the place, then most likely you missed this step and it's automatically selecting and building with the Ninja generator. This also gives it an explicit CMake option to build with nmake makefiles, which is what we want. The last thing that we want to consider here is our build directory. So you'll see here in a second that any Helios project typically has an empty directory within it called build. And that's the typical place where we build our projects. It puts all the compiled information needed to run within that directory. By default, CLion uses a bit more explicit of a directory name. So it's going to select by default cmake-build-debug. This could be whatever we want. It's just the name of a folder where it's going to put all of the build information. But let's just change it to build only because that's kind of the typical way of doing it within Helios. All right, and one last thing is, if you remember earlier when you were setting up CUDA, I mentioned that if you have a very old GPU and your compute capability is 3.5, then there are some special build arguments that you have to enable. And so this is the part where we do that. So if you have an old GPU with compute capability 3.5, then you click into this box for build options and then type in this string here, which is -d optics _version_legacy equals on. And that basically tells Helios to build with the legacy optics version, as well as it allows you to build CUDA with compute capability of 3.5. So in that case, you want to enable this option. If you don't have an old GPU and your compute capability is 5 or greater, then you don't want to add this flag because you want to build with the newer optics and the newer compute capability. And after that, we can go ahead and click OK to exit out of here. And that should be everything that we need to start building and testing our first Helios project. So over here on the left are all the directories within the Helios repo. And we want to come down to this one called samples, which has a lot of different sample projects that we can run. Many of these are just running the self-test for each one of the plugins, so there's not a whole lot to them. We could use these just to verify that our install worked correctly and we can build projects. So the first one we're going to try out is the simplest one, which is going to be context self-test. So if we expand this, we're going to find 3 different things in this folder. The first one is that empty build folder that I mentioned. So this is the typical place where we're going to build our project. The second one is a cmakelist.txt file. This gives all the information that the project needs to actually build it. We'll go into this in much more depth in future videos. And the last one is this main.cpp file. This contains the code for our main function or main routine within this particular project. So in order to build this project, we come to our cmakelist.txt file, right click on it, and then go to load cmake project. And if we want to see what's going on, we can come down to the bottom left to this cmake tab. And if we open it, it's going to give us all the output for the build part. So this is running cmake to configure our project. And if it gets all the way to the bottom and says finished, that means that it built correctly. If it gives errors, then that means there was an issue with CMake in setting up the project. So it did build correctly, so we're good to move to this next step, which is compiling. So we come up here to this top menu bar here. We have a couple of different options. The first thing we want to verify is that it automatically chose context underscore self-test as our target. And then we could either just build the project, which is just compiling it, or if we hit this play button, that's going to compile it as well as run it. So let's just go ahead and compile and run. And you'll see that it came over to this messages tab in the lower left, and this gives us the output of the compilation. And so it's going to go ahead and build all of the different files and routines needed for this particular project. And once it gets to 100% and successfully built, you'll notice that it automatically brought us over to this run tab and gives us the output of the run. So this is the output from that particular run. And then if it says process finished with exit code 0, that means it ran successfully. If it has some exit code other than 0, that means that it did not run successfully. Now we'll demonstrate how to do basically the same thing, but instead using Visual Studio Code. And just as a disclaimer, I'm not an expert in Visual Studio Code. I typically don't use it myself, and so if you're more of an advanced user, you might know of better ways to do this, but this is kind of a basic setup and run in VS Code. So the first thing that we're going to do is download and install VS Code. Then we'll open it up and pull Helios code from GitHub. Then we'll install the CMake Tools add-in, which will allow us to run CMake projects in VS Code. And then we'll set up a VS CMake project. Okay, let's open up our web browser here so that we can go and download VS Code. I'm just going to type in Visual Studio Code download. You can click the option here, download our version for Windows. And let's finish downloading. We can open up the installer and run that. And we can just click through, accept the defaults. I'll go ahead and create a desktop icon. And once it's done, we can go ahead and launch VS Code. And it's going to ask you a few things about the initial configuration, the look that you want. You can click next section once you decide which one that you want. And then finally, mark done is going to take you to the main home screen. All right, if we had already checked out the Helios source code from the GitHub repository and had it somewhere on our computer, we could go to Open Folder and browse to that location. But we can go ahead and pull it directly from Git within Visual Studio Code. So we just need to type in the URL for the GitHub repository, https://www.github.com/plant simulation lab with capitals starting each word /Helios. And then if we were to click on this part, clone from GitHub, this would actually prompt us for our password to GitHub. It would link our account and it would allow you to check out different repositories within your account. But here we don't need to do all that. If we just hit enter, it should just be able to pull it directly without linking your account. So you need to tell it somewhere to put the source code. Let's just put it on the desktop and then select as repository destination. So it should go and download the Helios source code from GitHub and then put it on the desktop. Okay, we can go ahead and open that. And here we have our Helios source code. And the next thing that we need to install are the CMake tools for VS Code, because it doesn't have CMake support built in. So if we come over here on the left side to extensions, which are these little boxes, click on that. And then we can search for CMake tools and then click install. So if we click Control-Shift-P and type CMake, it will give us the different options that we have for CMake, things that we can run. Let's go ahead and click Configure. And then it's going to ask us for the path to a CMake list.txt file that we want to build as part of our base directory. To start, we're going to run the context self-test, which is in the samples directory. So we can scroll down here to context self-test /CMake list.txt. And you'll notice that we've got this new folder that was created called .vs code. It contains the settings.json file. So within VS Code, it writes the settings to various JSON files. And if you open these up, it's going to have some options set within there. So this is how you could go back and change those if you wanted to. So it set our source directory as our samples /context self-test, which contains a CMake list.txt file that's going to tell us how to build. So we could also browse over here. You can see under samples and then context self-test. We've got our project here and our CMake list.txt file, which is going to be our top level CMake list that's going to tell it how to build. So you'll notice down here that it gave this little error related to ctest. I'm not exactly sure how to get that to go away. It just automatically runs ctest when you build for the first time. The easiest way that I found to fix this is just to close out of VS Code and then reopen it. And you only have to do this once. It seems like once you do that, then it will tend to fix that issue. Okay, so now you can see that it set up a bunch of things and it didn't give that error again. So it looks like it did successfully configure our project, but there's one thing left that we need to fix here that we want to change the way that it does things. So you'll notice that after that configure, it added this directory called build in the base Helios file structure. And normally when you build a project, you want to build it within that project directory. Technically, you could build your Helios project anywhere that you want, but to keep them separate, we usually put them in a folder called build within our project. So here you can see that it put it in the base directory, we want to tell it to build here within the context self-test directory. So the way that we do that is to come into this manage option here with this little gear icon in the lower left. If we click on that and then go to settings, and then expand this extensions option and then find CMake tools. And then if you browse down here, you'll find this option called build directory. And so this is what tells it where to build to. And you can see it's currently set as our workspace folder, which is just the main Helios directory /build. So we don't want that. Let's change this to samples context _ self-test /build. And if you click on this icon in the upper right where it says open settings, this is going to open the JSON file that it just wrote to for CMake. So this CMake build directory field is now set with the path to that directory where we want to build to. So we can close out of that, close out of our settings. And now let's go ahead and reconfigure. So if we hit Control-Shift-P and then go to configure. Okay, now you can see that it gave us this message that says build files have been written to context self-test /build, and you notice that it's now highlighted in green. So let's go ahead and delete that last one that was created. We don't need that. All right, and now things are set up the way that we would like them to be. So I can close out of this settings.json. If I just open up the main CPP in the context self-test, this is the main routine that it's going to run. All it does is calls the context self-test. It's a very simple program, but we're going to just use that as a test here. You'll also notice that we've got a few extra options here down in this bottom toolbar. Starting from the left, we've got our CMake, get out of here. We've got our CMake build variant. So if we click on this, it allows us to select from different build variants. So there are 3 different build variants that you can use with Helios. The first being debug. So as this says, debug basically disables all optimizations and then includes some different debug information for if you want to debug your program. This will give you things like line numbers of where errors happen and things that make debugging much easier. There's also release. So as this says, it enables compiler optimizations. So release is going to be typically 3 to 5 times faster than debug, but it's going to turn off debug information. And then you've got this rel with deb info, which stands for release with debug info. This is going to basically enable the compiler optimization, so it will be fast, and it will also build with debug information. But this build variant is usually not recommended because the problem is when you turn on compiler optimizations, it can mess with some of the debug information. So it can change line numbers based on the optimization and things like that. So it can give you misleading information. So we're going to build with debug, which is already set. The next option here is our kit. So if we click on this, it will allow us to choose the kit, which is basically just our compiler that we want to use. So it already detected that we have Visual Studio Community installed, and I'm going to use AMD 64 or x64 because that's my architecture. And then we have this build button and then the target that we want to build. So it already picked up that we wanted to build the context self-test target. But basically that's the one that's the executable. It has .exe and says executable. These are other targets that are built with the project, but they're not executable. So you always want to find the .exe executable and click on that. All right, so let's go ahead and build. So this is going to run our compiler. It's going to go through and build all of these different files here. And you should get to the end. It should say build finished with exit code 0. It should produce this context self-test.exe executable file. We can just take a peek into this build directory within context self-test, and it has a bunch of things, but among this should be this context self-test.exe. And if we click this play button here, it should launch that executable. And so it should say running context self-test and then passed, indicating that everything worked as expected. So that's our first test. This is about the simplest project that we can run. So let's move on and also test that our visualizer is working. So visualizer essentially opens up a window for visualization that we can use when we're running different projects. So let's test to make sure that one works. This will also demonstrate how to change projects within VS Code, which is a little bit more clunky than when you change projects in CLion. Okay, so there's basically two things that we need to do in order to change projects. The first thing is we need to come back to this folder .vs code that was created in this settings.json, and we want to change our source directory. So instead of running context self-test, we're going to run visualizer. So sample/visualizer, and then you can hit Control S to save that file. Just for reference, if you come down to this samples directory, we can find visualizer, and this is the project that we're going to run. So it's running through a little bit more complicated of a program here. This is going to allow us to test our visualizer. The other thing that we want to change is where it's going to build to. So we don't want to build in context self-test anymore. We'd like to build to the build folder within the visualizer project. So again, let's come back to our manage gear icon here, go to settings, and we could edit here our build directory, or you could click this little icon up here to settings and just type in directly. So we want to go sample/visualizer and then save that. Can close out of here. And then we want to go ahead and reconfigure. So we can do Control-Shift-P and then CMake configure. So take a close look at the end. If you get the error, that ctest error before that we saw, then try clicking out of Visual Studio, so closing out of it and then opening it back up, and that should get rid of that ctest error if you see that. Okay, so now we should be able to build. And I made a simple mistake here. You can see that it's giving an error saying that we're still referencing context self-test, and so I forgot to come down here and change the build target. So we now want to go and find the visualizer executable. So it's called visualizer chess.exe. So if I change to that one and then change to visualizer chess here. So now we don't have our context self-test, we have visualizer chess, and now we should be able to build. And it did indeed builds. Let's hit play to go ahead and run it. And it should open up this graphics window with this little chessboard showing that it was able to successfully run this visualizer test. So graphics are working in our case. Let's close out of that. Let's close out of here. And then we're going to do one final test, which is to make sure that we can run GPU and CUDA based projects as well. So I'm going to minimize these here. So let's go through all those steps again to change our project. So first, edit this settings.json And the project that we're going to run is in samples, and we're going to run energy balance underscore self test. So save that, Control S. It's going to try rebuilding it again. We also need to change our build directory. So go to our settings. I can just cut straight to this one. So let's change our build directory to, again, energy balance self test. And save that. Exit, exit. All right, so now let's reconfigure so that it will give us that new target that we can run. So Control-Shift-P, reconfigure. And we want to note one important output message that it's given us here, which is that it found CUDA. So if we take a look at this line here, it let us know that it found CUDA, it found version 12.2, and here's the path where it found it. So it was able to find that automatically. If you get some error messages that say CUDA Toolkit could not be found, then what you need to do is add it to the path. So in that case, it wasn't added to the system path automatically when you installed CUDA, so you're going to have to install it manually. All right, so let's go ahead and build. Oh, I did the same mistake again. We need to change to our energy balance self-test executable. And then change our target also. Changed it on its own. Now we can click build. All right, and we should get to build finished with exit code 0. Once we get there, we can click the play button. And it should say running energy balance model self-test passed, indicating that it worked correctly. So there we have it. We've run our 3 different tests verifying that we can run a basic program, that our graphics are working, and that our GPU-based programs are working. Okay, the very last approach that we're going to talk about for running Helios on Windows is using the command line in combination with a text editor of your choice. And the easiest way that I found for doing this is to install Windows Subsystem for Linux. You can use other Linux environments within Windows, but I found that they are much more difficult to set up. This is really the easiest way to do it. So first thing we're going to do is install the Windows Subsystem for Linux. You can install different flavors of Linux like Ubuntu or Debian. And that's going to give you an app that you can then open up. And you'll basically at that point have a Linux command line in front of you. For all intents and purposes, it will be the same as if you're working from an actual Linux computer. So I'm not going to go through how to set up and run Helios on Linux from the command line, because we'll have a separate video on how to do that. And so at that point, I would just refer you to that video. So in my experience, installing Windows Subsystem for Linux is either super easy, or if it doesn't go right the first time, then there are potentially a bunch of different steps that you have to go through in order to get it working. So the first thing that we want to do is open up a command prompt or PowerShell. So you can search for PowerShell. And you want to make sure and run this as administrator. So you can right click run as administrator if you're not already. So let's open up our PowerShell. And basically all we need to do is run a single command, which is wsl -- install. And then if we hit enter, if all goes well, it should more or less install from there. In this computer, it has too old of a Windows Enterprise version, so it's going to error out. But if you encounter an error, I'll link a few different resources online that take you through different steps or options to install if you run into various errors. It's beyond the scope of this video to try and walk through all those different options if it doesn't work just installing it this way. So had it worked, again, you'll end up with an app that, let's say that we chose to install Ubuntu, then you would end up with an app that's called Ubuntu that you could go open, and it will basically open up a Linux command line from there. Go ahead and watch the video on the Helios Linux install to learn about how to install CMake as well as the C++ compilers and how to build and install from the command line. All right, and that is it for this video. Thanks for watching. If you want to learn how to do this on other operating systems, there will be additional videos that will be linked below that you can follow.